Hello, I'm Sean Powers, and I'm here to remind you to learn everything, do what you love, and most importantly, be kind. Now, today we are diving back into the Linux Plus certification prep course. Whether you're hoping to get certified, prepping for that, or if you just want to learn Linux a little bit more thoroughly, this video hopefully will benefit you. And specifically today, we're looking at section 131, which is actually a part of section 1.3 or objective 1.3. I just split it up into multiple videos, so I'm calling this one 1.3.1. Anyway, we're going to look at kind of a hodgepodge of the topics inside this objective. Basically, we're going to look at how we can identify the storage hardware on our systems, how we can partition them into usable space for our systems, and then how we can look at how much disk space is used on the systems that are in place and then ones that we create as well. Now, there's a couple different ways to do most things we're going to look at. For example, Fdisk and parted or parted, depending, it's for partition editor. They do the same exact thing, but we're going to look at both. And same thing over here. You know, a lot of these looking at block devices do the same sort of thing, but they're going to work differently in different circumstances. Before we get started, a quick thank you to my Patreon supporters. You make it so that I can continue to do this regularly and provide this training for free for anyone who it might benefit. I am so incredibly grateful. If that's something that you want to do, you can join my Patreon supporters. I'll put a link in the description to my Patreon page, but it's certainly not required. Everybody is welcome to join in on this and on our Discord. So I hope to see you there, or at the very least, I hope to see you in the comments on these videos. Now, let's dive in to working with disk partitions and block devices. All right, so we're here on an Ubuntu system, and this is a virtual machine, but it has one hard drive that is in use, and then I added another virtual drive that we can play with. But I want to show you a couple tools, specifically the ones that are listed on the objective. So we're going to start with BLK for block ID, and of all the tools, this might be the least helpful unless you're looking for things like the UUID of a partition that's in use. But this will show you partitions, block devices that are currently in use on the system, like they're mounted. This one is an ext4 device, and it will give you that UUID, but this will just give you a list of the block devices that are in use on your system. But if you're trying to add another new device, it's not going to show up because you have a chicken and an egg thing, right? You have to have it in use before block ID or BLK ID will show it to you. So we can also do a couple other things. We can do LSSCSI or LSSCSI, and we'll get a list of all the SCSI devices on the system. And I know some of you are like, whoa, 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 whoa. Why are the serial ATA devices being shown as SCSI devices? SCSI means something different. Serial attached ATA is not SCSI. And you are technically very, very correct. However, most device drivers, most storage block device drivers refer to pretty much every device as a SCSI device these days, just so that they're easier to find all in one place. So you'll see here we have the CD-ROM is dev SR0, and then we have two actual hard drive block devices that are virtualized serial ATAs. One is SDA and one is SDB, but this doesn't show you anything other than here they are. We can actually look at our third tool for identifying block devices. That one is LSBLK, and this is going to show us, this is annoying, but if we press enter, it's going to show us all of the devices, but that includes loopback devices that are used in Ubuntu specifically for snap programs or applications that are installed, and that's super annoying. I don't want to have all these loop devices listed, and if you do LSBLK-H, you can see that there are options for only showing certain types of devices, but I just want to get rid of certain types of devices. So we could do -E and exclude the loopback major device number, but I just have an easier way to remember than worrying about the flags that you have here. I just like to do LSBLK and pipe that through grep-v loop. Now, grep-v we've covered in previous videos, but basically it shows you everything but what you specify. It's like, I want you to show me everything in the contents that I'm grepping except for the thing I'm specifying. So this should show us every line except ones that include loop. So if I press enter, look at that. It's a nice small list of the things that we have. And why I like this more than LSSCSI is it shows us not only the devices, but it also shows us a nice tree view of the partitions if they exist. So SDA is our current booted hard drive, and it shows that there are 3 partitions. There's one here, there's the EFI, the UEFI partition, and then SDA3 is our main root partition. And it's just really, really verbose in the information that it's showing you. Now, it also shows us the other 2 SCSI devices, SDB, but there's no tree listing here because SDB is a brand new hard drive that is not partitioned. That's what we're going to do next. And so that's listed. And then, of course, our CD-ROM drive is SR0. It's listed as well. So that's how you can kind of see the block devices that are in your system. And now that we've identified that, we can actually go through and partition that new hard drive that we've discovered on our system. Okay, so like I said, there's 2 tools to do that: parted or parted. It's like partition editor, or Fdisk. And we'll just start with one arbitrarily. So we're going to say first we have to be root, because again, we're editing like actual hardware devices. So we're going to say sudo fdisk dev sdb for that new block device. Press enter. It's going to ask for my password. And then we get this text only interface for Fdisk. Now, Fdisk is kind of older, and the reason parted or parted exists is because there was a period of time where Fdisk did not work for newer large drives. Now, Fdisk has been modified, so it will work on pretty much every drive, and parted will as well. So you can use one or the other. But for a while, Fdisk was kind of crippled and only worked for older disks. That's not the case anymore, and I don't think that'll be something you're questioned on, but hey, now you know. So anyway, we're inside here, and generally the first thing I do, because I never remember all the commands, is to do just like it says. It says M for help, so I'll press M, press enter, and it will give me a list of the different commands that I can do when I'm in here. So first things first, we could print the existing partition table. So that will just show us what's on the drive itself. So I'm going to press P, press enter, and it will give us the information about it. It looks like it's a 10 gigabyte drive, and it looks like there's no other partition information on there at all. So let's create, I'm going to scroll up here so we can look. Let's create a new partition using Fdisk. To do that, we use N for new partition. Okay, so I'm going to press N, and it will walk us through this, which is really nice. So press N, enter. It's going to say, okay, what kind of partition would you like to create, primary or extended? And I'm going to say primary. Now, quick side note, the reason it's asking it this way is because this happens to be a DOS partition table by default. It said that, where did it say that? Disk label type is DOS. If we made a GPT partition table, which we could do with the G command, then we wouldn't have to worry about primary and extended. We've learned about that in previous videos as well, whereas the older MBR master boot record format is a little bit different. Anyway, we're going to just use the defaults here. So I'm going to say P for primary partition number 1 through 4. I'm going to say 1. Again, default, I'll just press enter. The first sector, and it gives us the first usable sector here, and it's 2048. So again, I'm going to accept the default. And the last sector, it's going to default to the last sector of this hard drive. I'm going to press enter again. And now, if we do P for print out the partition table, we should see, along with that information that we had before, now it shows we have dev SDB1, and it's 10 gigabytes, and it's the Linux type of partition. It's labeled as a Linux partition. We could change that if we wanted it to be RAID or something, but that's a whole nother video. Anyway, so it's here. Now, if we want to quit, we need to write the partition table to the disk. Right now, it's just making all of these kind of like staged in memory, and I don't remember how to get out, so I'm going to press M again, and it'll show us, it'll say, okay, save and exit. There's 2 ways we can do it. If we do W, it's going to write the table to the disk. Remember I said all these changes are just kind of like staged in memory. If we type W, it's going to save it and exit. If we do Q, it's not going to save any of the changes. It's just going to exit right out. Okay. I'm going to save the changes because I want to do something cool after this. So I'm going to do W to save the changes. It says that it's been altered, calling IOCTL to reread the partition table. That part's going to be important in a second, and syncing the disks. So now let's do LSBLK. I'm going to pipe that through grit-v loop. And now look at that. So we had our partitions from before, and now we have SDB1. Now we haven't written a file system to it, but we have a partition that is now active. So let's use the other program to do that, which is parted or parted. But I need to get rid of this partition, right? I want to have a fresh hard drive like we did before. So there's a couple ways we could do it. We could go in with Fdisk and delete the partition and then save that to disk. But let's do a fancy thing using a tool that we've looked at in a previous video. I'm going to do sudo dd input file equals dev 0, output file equals dev sdb, count equals 100. I'll press enter. Okay, so it has written 50 kilobits. I think that's going to be enough to wipe out that partition table. It should be. Now let's do LSBLK. Oh, and it already automatically did it. It didn't wipe it out. Okay, I was hoping I would have to, the kernel noticed that I completely wiped out that partition, and so it doesn't show it right here. But there's another tool that we actually need to talk about, which is part probe. And what part probe does is it tells the kernel, hey, I've made a change to the partitions. You really need to look at our partition table again to make sure you have a good idea of what's going on. Like I said, it automatically did it when I did that dd command and wiped out that partition table that we wrote. However, it is clean, and part probe is a way to make sure that the kernel has a current picture of what's going on. So let's do it the other way now. We're going to say sudo parted or parted dev sdb. And now this is the same sort of a thing. It's just a command line interface. There is a graphical user version of parted called gparted. We're not going to look at that because generally with the command or with the certifications, they only look at command line tools. So we're just going to look at the command line version of it. And just like the other one, it told us how to get help. It says here, type help to get a list of commands. So I'm going to type help, and we'll scroll up a little. And first we'll look at this print, which will display the partition table. So let's say print unrecognized disk label, and that's because we, use DD and we just wrote to it. So basically, it says that there's an unknown partition table. Basically, it's not usable at all. It's just kind of a raw disk, if you will. We could create a partition table. So let's do that. I think if we actually made a partition, it would make a partition table first. But let's create the partition table. So let's do mk table. If we hit enter, I wonder if it will ask us what type. Yes, new disk label type. Let's do GPT this time. Okay, and now let's do print. And sure enough, now we have a GPT label, but there are no partitions. So to do that, I believe it was mkpart. Yeah, okay. mkpart, partition name. Let's name it main. File system type. It looks like it's going to actually put a file system on it for us. I'm going to do ext4. Start 0 and oh, it actually doesn't have any defaults. That's been in the butt. Okay, let's start again. mkpart, partition name, main, file system type ext4. Start is going to be at 1, and the end. Now these are in megabytes, and it's a 10 gigabyte thing. So I'm going to say 10,000, and there. Now if we do print, we should see. Sure enough, it is 999999, but it's a 10 gigabyte partition ext4. And now how do we quit? If we type help, we can see that in order to quit, we just type quit. Okay, now let's do LSBLK, and we'll see, sure enough, our partition is back. So we have our partition there again, and that's all there is to partitioning up a drive using either Fdisk or parted. I actually prefer Fdisk, and you can tell it's the one I use more often. I actually purposefully did not go in and do everything in advance. I wanted to make sure that I had to explore with you because I don't want you to think that I automatically remember all of the steps for every command. It is okay to go in and be like, all right, what am I looking for here? Like, oh, it says type help, so I'll look at the help, and then like, okay, this is what I want, and then try it out. I'm like, oh, okay, it doesn't default to the biggest partition that you can do, and so you kind of have to feel around and do stuff, and that's okay. That's actually how things are normally done. I don't want anybody to get the idea that you automatically just know intuitively that it will require you to know the number of megabytes in the partition that you want, etc., etc. Anyway, that is how you make a partition. The one last thing to look at is once the partitions are made and they're like mounted on our system, how do we look at how much space is being used, right? I mean, we've identified the block devices. We see how to create them. We're going to mount them in a later video. But the ones that are mounted, how do we look at the amount of space that's being used? Well, there are two tools that we're going to use to look at the amount of space being used. But before we do that, we need to look at FCstat. Now, this is something that is mentioned on the objectives, and this is only viable, or this only makes sense if you have a fiber channel adapter on your system and you're connecting to devices over fiber channel. So I don't have fiber channel, so I can't actually demonstrate that. I can't even show you the tool, but this is the tool. It's FCstat, and it has like some command line flags that will just show you information, just kind of like the LSCSI did and LSBLK, but this will give you information specific to fiber channel connections that are on the system. If you have those drivers, you'll be able to install FCstat to get stuff. And thank you, IBM, for putting not only an example, but actually the output of an example as well. This is exactly what it will look like if we had a fiber channel adapter. So FCstat, the name of fiber channel adapter, and then it will show you the information about that. I do, however, have a file system. And so let's clear this screen. And the two tools I want to show you, and you've probably seen me use both of them in previous videos. But first of all is DF. Now, DF will show us the blocks in use on the mounted file systems on our currently running computer. Now, I usually like to do DF-H for human readable, and you'll see the difference. Ooh, you got to spell it right, DF-H. And I like it because this shows me 1K blocks, but I don't want to do 1024 times whatever math in my head. And so I like to do -H because it gives us human readable results like in megabytes and gigabytes. So I always do DF-H. And basically this just shows us all of the file systems that are mounted on our system, including the temp file system. So like our run file system is 200 megabytes in size. Currently 1.3 is used. Same with TempFS, looks like it has a gigabyte, or this TempFS has a gigabyte. It's mounted on DevShim. This is actually going to be a future video where I use DevShim a lot in my bash scripting as a temporary storage location. That's just a foreshadowing of a upcoming video. It has nothing to do with Linux Plus. But anyway, these are RAM disks, basically. These TempFS, these are RAM disks that are mounted in the RAM on your system. This is the UEFI partition. And then of course, where did I pass it up here? This is the main partition on our system, dev SDA3, which is 20 gigabytes, 10 gigabytes of it is used. We have 8.2 gigabytes available. Some of that is due to inode usage, etc. But anyway, it tells us that it's 55% used, and where it's mounted, the root partition, right? That's the only hard drive that we really have mounted on this system right now. DF is a great tool. The other one is DU, which doesn't show us the size of partitions. It shows us individual files and folders, how much space they use. But it's kind of a pain in the butt at first. I mean, if you just type DU, I'll show you. You do this, and just like the find command will recursively find every single file and folder that exists in from where you are currently, down every folder. You'll see it like went down every single folder here. This isn't exactly what I want. This shows how many blocks are in use by this particular file. That's not as useful for me. I also use -H for here, and that will show us, well, let's just do -H just to show you. If we do this, it'll show us in kilobytes and megabytes and or gigabytes. But usually what I will do, I don't think there's anything in this folder, right? No, let's go to etc. Okay, so there's a bunch of stuff in here. I will do something like DU-H for human readable, and then --summarize, which will give me a summary of, like, if it comes across a folder, rather than going in the folder and showing all the various things in there, it will just add up all the stuff inside the folder and give a result for the entire folder. Let's do a summary of how much stuff is in the VMware tools folder. So VMware tools, and it will say, okay, there's 280 kilobytes in the VMware tools folder. Okay, and that's usually how I do it. DU is disk usage, and I will usually say --summarize, and then what it is I want to see. And this is really useful if you're trying to find like, okay, which folder in my home directory is using all of the storage, and you find out, oh, it's my videos folder, happens to be like 85 gigabytes or something like that. Anyway, these are the main tools for checking out block devices on your system, how to partition them. I encourage you to play around, especially if you have a virtual machine. Create a couple block devices and partition them and format them and play with them and use DD to completely destroy them and see what happens, because experimenting and playing really is the best way to figure out how all of these different things work. But now you have some tools to actually look at your file system, look at your devices, see how much space they use and how to manipulate them. And if you have Fiber Channel, you know that you can use FCstat, but I don't have Fiber Channel. So in fact, I don't think I've ever used FCstat in my entire life, but that doesn't mean it's not important to know, especially if you're going to take the Linux Plus exam. Anyway, I hope this was helpful, and I look forward to seeing you on the next video.